All right, let's dive right into this explainer. Today, we're unpacking one of the most profound and, frankly, fascinating medical phenomena out there, the experience of severe, very real pain in a limb that no longer physically exists. It completely challenges everything we intuitively think we know about how pain works, and it sits right at this incredible intersection of surgery, neuroscience, and psychology.
To really get a grip on this, we kind of have to look back at how our understanding has evolved over time. Way back in 1564, a military surgeon named Ambrose Paré first documented patients complaining of pain in amputated limbs, but for centuries it was horribly misunderstood. Honestly, it wasn't until the 1860s, while treating Civil War injuries, that neurologist Silas Weir Mitchell officially coined the term phantom limb pain. Even then, it carried this massive psychological stigma. Patients suffered in total silence, basically being told it was all in their heads. Well, today, thanks to modern neuroscience, we know for sure it's not some psychological fabrication. It's a highly measurable neurological reality of the brain literally rewiring itself.
Now, you might be thinking, this is just some incredibly rare freak quirk of medicine. Well, absolutely not. We're talking about a staggering 30 to 80% of patients developing chronic pain after an amputation. That means the vast majority of people going through this life-altering surgery are left fighting a phantom. So here's our roadmap for this explainer. We'll start with the phantom limb mystery, move into the types of post-amputation pain, dig into the neuroscience of pain, look at prevention and risk factors, and wrap up with modern pain management. All right, part one, the phantom limb mystery, moving past the stigma.
Which brings us to the actual medical framework we use today. We've got this overarching umbrella term, post-amputation pain, or PAP for short. This sets a really clinical, structured stage for us. Because you see, it isn't just one single type of phantom ache. There's a whole cluster of specific subtypes here, and each one requires a totally different medical approach.
Moving right along to Section 2, Types of Post-Amputation Pain, Mapping the Sensation.
Okay, so the absolutely crucial point here is drawing a hard line between the two main types. On one side, we have residual limb pain, or RLP. Think of this as mechanical, localized pain right at or just above the surgical site, usually caused by poor healing, scar tissue, or maybe a badly fitting prosthetic. On the flip side, we've got phantom limb pain, PLP. This is that distal neurological pain felt literally in the absent limb itself. Keeping this framework locked in your head, RLP is local and physical, PLP is distal and neurological, is going to help you understand everything else we cover today.
But wait, it gets even weirder, honestly. We also have to define phantom limb sensation, or PLS. Now, this isn't pain. It's just an incredibly strange perception that the missing limb is, well, still hanging around. Patients often describe this wild illusion called telescoping, where the distal part of the limb, say the missing hand, feels like it's floating closer and closer to the amputation stump. It beautifully illustrates just how much the brain struggles to map a body part that has suddenly vanished.
Which leads us perfectly into Section 3, the neuroscience of pain, wires crossed.
So let's look under the hood. The path of pain is complex, and the nervous system can basically misfire in three distinct areas. First up, peripheral mechanisms, right at the stump itself, where injured nerve endings fire off spontaneous, totally erratic signals called ectopic discharges. Second, we have spinal cord mechanisms, where the dorsal horn gets so overwhelmed by painful stimuli that it literally turns up the volume on pain, a process called central sensitization. And third, supraspinal mechanisms. This means the brain itself is actually rewiring its own sensory map. And this is where we see an absolutely unbelievable display of neuroplasticity. When a limb is removed, the real estate in the brain that used to receive signals from it, it doesn't just shut down, it gets hijacked by neighboring areas. Because the brain's sensory map gets its wires totally crossed, a simple touch in your shoulder or arm can physically be felt as a touch or even a sharp pain in a hand that isn't even there anymore.
All right, on to Section 4, Prevention and Risk Factors, before the surgery.
So how do we stop it? Medical pros use what are called Enhanced Recovery After Surgery, or ERAS protocols. Setting expectations with the patient is key, but the real magic here is preemptive anesthesia. We're talking about administering epidural analgesia up to 48 hours before the surgery even happens, alongside continuous peripheral nerve blocks. It essentially quiets the nervous system down before the trauma of amputation even hits. Doing this significantly drops the long-term onset of phantom limb pain.
But, there are factors totally outside the surgeon's control. Check this out.
Genetics play a shockingly massive role, accounting for up to 70% of how a patient will perceive generalized chronic pain. This genetic predisposition interacts incredibly closely with environmental and psychological factors, like pre-surgical anxiety, depression, and personal coping strategies. It really goes to show us that pain isn't just physical damage, it's a deeply personalized biological experience.
And that brings us to our final part, Section 5, Modern Pain Management, Brain Hacking.
Let's break down this pharmacological data for a second, right from the source. You'll notice that your standard painkillers, like NSAIDs, think ibuprofen, they work great for the physical stump pain of RLP, but they are basically useless for phantom limb pain. To fight the phantom, you have to target the nerves themselves. Drugs like gabapentin, an anticonvulsant, or ketamine, an NMDA receptor antagonist, show a lot more promise here because they're going after the misfiring nervous system, not just localized inflammation.
But drugs alone often just don't cut it, which poses a pretty fascinating riddle, right? How exactly do you physically treat a limb that physically doesn't exist? Well, doctors have had to step way outside the pharmacy for this one and dive straight into the world of cutting-edge, non-pharmacological rehab.
Enter mirror therapy. I know, it sounds a bit like a parlor trick, but it is pure, hardcore neuroscience. The patient puts their intact limb in front of a mirror, hiding the amputated stump right behind it. By simply moving the intact limb and watching its reflection, they activate mirror neurons in the brain. That visual input literally tricks the brain into seeing the missing limb moving normally, allowing the patient to mentally and physically unclench a phantom limb that felt agonizingly paralyzed.
And technology is taking this even further. We now have these incredibly advanced prostheses, like Sauerbach and myoelectric models, that give actual somatosensory feedback back to the user. So instead of just being a cosmetic piece of plastic, these devices send real sensory signals back to the body, which really helps to reverse those maladaptive brain pathways. Basically, giving the brain actual work to do with the stump reduces the phantom pain.
But the absolute frontier right now is virtual reality. Immersive VR training is showing insane success rates. We're talking reducing phantom limb pain by 50 to 90% in some studies. By dropping the patient into a virtual world where they can actually see and control a digital version of their missing limb, the brain is fully led to believe the limb is totally intact and controllable. I mean, it is literal brain hacking.
Ultimately, though, you can have all the cool tech in the world, but it has to be paired with psychosocial care. Treating post-amputation pain requires a deeply empathetic, whole-person approach. It's about combining these physical and neurological treatments with psychological interventions, chronic pain acceptance, and mind-body therapies like biofeedback. You really have to treat the mind and the social well-being of the patient, not just their physical symptoms.
Which leaves us with this final, kind of mind-blowing thought. We've just seen how the brain can literally manufacture agonizing pain for a body part that is sitting miles away in a biohazard bin simply because of some mixed-up neural maps. If severe pain can exist entirely within the brain's remapped networks, and if just using simple mirrors or VR can hack that system to turn the pain off, what else is the human brain capable of rewiring? It's an absolute testament to the staggering power of neuroplasticity and a solid reminder of just how much we still have left to discover about ourselves. Thanks for joining me on this explainer. I really hope it sparked your curiosity as much as it did mine.